Our next speaker is Prasad Modali. He's a product manager of Silicon at Google. Before that, he was with Intel Corporation for almost 15 years. And Prasad is going to talk about how we can effectively use drones in the future to deliver medicine in rural India and other rural parts of the world. So welcome, Prasad, and I'll let you take it away. If you have slides, we can share your screen.
I do not have slides, but I can.
That's okay too.
I was thinking it's just easy to have a conversation. First of all, Roger, thank you for having me over. Ramana, thank you for inviting me. Apologies for being a little bit late here. I'm jumping off a different call into this call. So first of all, drones are near and dear to me. Coming from Silicon, it's very different and it's more system level problem. I was fortunate to be able to be part of a team that built a few drone products at Intel in several years ago, before I joined Google, and we were heavily focused at that point on bringing autonomous behavior to drones. This is one of the problem areas, an active research area even today, in terms of, in order for us to make drones very useful, they need to be more and more autonomous and be able to safely take off and safely land and safely navigate along the way with as little human intervention as possible. So, in fact, I think the market, the market is growing. Roughly, it is estimated last year around $90 million. The medical health market for drones. It is expected to be around $400 million in 2025, according to some estimates. I do see, in terms of use cases, there are many different ways drones can help us. They can help us in delivering medicines to remote locations. They can help us in emergency situations. We previously worked with a company that would set up a temporary cell tower in cyclone-affected areas by lifting the base station with a drone, and so the whole several kilometer area underneath the cell tower could have now coverage, which otherwise wouldn't with the flooding situation. So that's just one example. There are many hospitals delivering blood samples and so on between the hospitals in the cities today, and that's a very interesting use case, because you can simply get across a couple of miles distance in the air, versus on surface it can take close to a half an hour or more, depending on the traffic situations. There are other use cases that we have explored, and I think several companies are exploring now, for telemedicine, creating a Wi-Fi hotspot. So we have done some experiments on this previously with AT&T, where we have installed a cellular connection on the drone, and the drone has a cellular backhaul, and it provides a Wi-Fi hotspot in the area where the drone is flying. So this allows applications like people who have Wi-Fi in their area, but they're not quite connected to the cellular. This provides cellular connectivity. So this is one example. Delivering defibrillators. There are some companies that are doing this. That's very in emergency situation, getting a defibrillator across at a short distances is quite useful. There are some gaps in technology, though. It's the drones, as much as we like them to be useful, they are very useful today under very constrained conditions. For example, drones cannot fly for very long periods. What happens is, typically when you increase the size of the battery on the drone becomes heavy, and that weight of the drone makes it draw more current from the battery. So the propellers need to work extra hard, so they draw more power from the battery. So there is this loop that forces drone to have roughly like 20 minutes to 30 minutes of battery life. So we cannot fly very far unless you have different type of alternate fuel. The other issue is the safety of these, and we need to improve the safety of the drones. We need to improve the reliability of the drones. And last but not least, there are a lot of companies working on making these drones more and more autonomous. The more autonomous we can make, what is autonomous, right? It really means that your ability to, let's imagine now you are running an operation where you have fleet of drones, like you could have 100 drones or you could have 200 drones that are delivering medical supplies or what have you to different locations. You need to be able to have a single operator or a small number of operators manage all these fleet of drones to pick up things they need to pick up, to fly over to locations they need to fly, deliver, return back, and so on and so forth. So this whole management of these means that the drones have to be as self-controlled as possible and not require manual intervention in order for this problem to scale. So these are some of the key points I wanted to bring.
So I wonder if I could ask Prasad, so here in the United States, drones have been hindered by FAA regulations for commercial use and also pretty strict privacy laws. Do we have the same problems in rural areas where they're really probably needed more?
I think definitely regulations are super important, and they can hinder the progress, but at the same time, if we don't have them, they can actually cause quite a few problems. So I kind of understand the both sides of the coin. I'm not up to speed on the latest on the regulations. There were, I remember, at least when I last checked, there were rules on piloting these drones in a certain height, so that they are in a safe buffer zone. That's one thing. In terms of privacy, yes, people using cameras on the drones, it's a concern for privacy. This has to be addressed. I think many companies are looking to figure out how to address privacy versus camera. One small technology that might be potentially useful in this space. Today, we use regular color cameras for navigation on the drones, but a lot of new companies are coming up with radar-based navigation technologies where you really don't need to see from the camera, but you can see with the radar signals what is in front of you and therefore be able to navigate. That's one approach. There is another set of camera sensor that is coming up that basically what it does is it figures out what is changing at every 1,000th of a second instead of capturing the image itself. So you never see the field of view is never the image, but it's more like if any changes in the pattern of what the drone is seeing. So this sort of technologies can help us introduce privacy support into the drone navigation and therefore not confuse privacy versus navigation capabilities for cameras.
Yeah, I see, and that's probably part of that automation that you were talking about, or I guess where drones can become partly autonomous. And I suspect to go over long distances, that'll have to happen.
That is correct. Yeah.
And that technology is advancing rapidly, isn't it? Or the bundle of technologies that go into.
Absolutely. So a lot of the technology need not be invented particularly for drones per se. We can reuse a lot of the mobile phone technology. If I may, the volume is driving the unit economics here. So what happens is a lot of the camera sensors, low power camera sensors, low power processors, all these things, they're actually coming from mobile industry that could be repurposed, that are being repurposed for drones.
I have a question for you. What is the weight that you can take the medical supplies? For example, supplies or medicines are not that heavy, but is there any limit on the weight of the medicines or some equipment like a defibrillator or anything like that? Is
Yeah,
there any limit on that?
that's a really good question. And there is no limit per se, but people are designing today. If you look at a lot of these companies that are doing the medical deliveries, they pick a particular drone which can carry a payload of a certain weight. So what that means is that the propellers, the battery system on the drone is designed in such a way that it can carry certain weight for a certain time, certain amount of time, roughly. That's kind of how it translates. So what that means is if you have larger payloads that you need to transport, you need to have a bigger capacity drone with bigger propellers and bigger battery, but you still end up with the same 20-minute, roughly 20-25-minute flight time.